In this video, we'll be looking into the fifth module, that is software quality of software engineering and project management subject. So this module is comparatively easier than third module and fourth module. In this video, we'll be covering all the important concepts, so stay tuned till the end. So first topic we have is the place of software quality in project planning. So in project planning, quality plays a very important role, right from the planning to execution. We should make sure that the quality is maintained. So the first step we have is to identify the project scope and objectives. So identification of objectives is pretty necessary so as to have streamlined approach or work towards the goal. And scope specifies the limitations of our project. Okay, after identifying these, further we move to identify the project infrastructure. Project infrastructure could be what are the standards which need to be followed and what are the hardware components or their specifications and all of that. Okay, and then how will our project be developed, in what manner will it be executed, and all of that. Then we analyze the project characteristics again. What are the characteristics of our project, what are the functionalities which we'll be inculcating, and all of that. Then we have identifying the product and activities of project. What are the products? So once we decide a project, we don't develop it in one go itself, right? So we divide it into parts, into tiny products, and then work towards completion of those products. So here we identify the product and activities related to the project. Then we review and publicize the plan, but before that we estimate the risk, efforts, and allocate the resources also. So reuse and publicize the plan is at this stage the overall aspect of the quality of our project are reviewed and considered here. So looking at the diagram here, firstly we have to select the project. This was the first step. Then we identify the project scope, objectives, the project infrastructure, and then we come to the project characteristics. From characteristics we identify the product and activities related to the product. Then we estimate the efforts, estimate the risk, and allocate the resources. And after that we reuse or publicize the plan. Once plan is done, we execute the plan. Execution of the plan is done, we modulate the low level planning. That is, we review it again when it comes to identifying the product. Okay, so this was about the place of software quality in project planning. This could be asked for 8 marks or 6 marks. So next, moving on, we have definition of software quality. So there are 3 specifications to define about software quality. The first one is functional specification, that is, what will the system do? What are the functionalities of the system? Then we have quality, what the software will do, Then we have quality specification, how well the function will operate, how well the software will operate. Then we have the resource specification, so what amount of memory, time, money, and all the resources would be spent. Okay, so that is about resource specification. So overcoming these specifications, next we have is defining software involves understanding both external user perspectives and internal developer considerations. So external qualities like user interface must align with internal factors like well-structured code. So when these two are in parallel, when these two align together, we can enhance the reliability by reducing the errors. So by mapping these external and internal factors, it helps us to align with the user expectations or the customer expectations. Next we have what are the measurement standards. So looking at the measurement standards, first one we have is ISO IEC 1593 2007 and fault per 1000 lines of code. So these are the measurement standards which are used to evaluate the software. For example, this ISO IEC 1593 2007 is a framework which is used to evaluate or measure the software quality. Like we have fault per 1000 lines of code. This is again a meaningful criteria to count the faults, how many faults are occurring in 1000 lines of code. Yeah, so these are measurement standards. Then we have direct and indirect. Direct means you directly measure the quality itself. Indirect means you make use of all the indicators which depict the quality presence. Okay, then we have setting the quality targets. So by setting quality targets also, we can specify what are the measurements we want, what are the improvements we want, and all these things should align with the goals or the user expectations. So this was about defining software quality. Next we have the importance of software quality. Why is software quality important? important. So because there are 4 points here, we need to expand these 4 points and write. So the first one is increasing critically as software. So increasing criticality of software. So as the software is increasingly used in safety critical applications, reliability becomes very important, right? So users and organizations heavily depend on computers. So which means the quality should be of high level, and not just the quality, even the safety should be considered here. Then we have the intangibility of software. Intangibility of software means like if you consider any physical tools, so like when it undergoes any changes, they are reflected. Like consider this pen, if I press it, it breaks. But then for software, it is not like that. Software cannot break directly, right? So but there could be changes done to the software quality. So it is very important for us to make sure that our software is intangible. It comprises of high quality. Its security, it is secure and properly configured. Then we have accumulating errors. So by performing software test, like by checking the software quality, we can accumulate all the errors. Once errors are accumulated, we can go through the errors, fix all the errors, or what are the bugs present, we can fix it. Okay. Then we have complex debugging phases. So complex debugging phases are like we come across whatever errors have occurred, and then we perform debugging. Here we identify the problem, then prioritize it, and then we start solving it efficiently. Thus we can overall increase the success rate of our project. So these are the 4 importance of software quality points to remember. Next we have is ISO IEC 9126 software quality characteristics. So there are 6 characteristics here which could be remembered as PERFUM. So P stands for portability, efficiency, usability, and then we have reliability, and then functionality, and we have maintainability. So we'll look into this one by one. So the first one we have is functionality. So in functionality, we make sure that the set of functions which our software project provides meets the user's requirements. So it includes all capabilities, like it has to be proper, it has to be complete, it should be secure, and all of that. Suitability means whether the software which we have written is suitable or not, suitable to the system. Then accuracy, whether it is error free or not. Then we have interoperability. Interoperability means if I run the same software in different system, will it run properly or not? Then we have security and compliance. That is the security aspect is maintained in that particular project or software. Then we have reliability. So reliability means we can rely on that particular software or not. That is, the software should be fault tolerant and recoverable. Okay, so there should not be any errors in it. Maturity is once the software is like after a certain time, it might be it might get exposed to errors and all of that. That should not happen. It should be error free. Fault tolerance. So it should have high level of fault tolerance. It should be developed in such a way that there are no faults at all. Then we have recoverability. So it should be we should be easily able to recover it. Then we have the usability. Usability are the efforts which are required to use the software easily, effectively, and efficiently. So it includes factors like understandability. It should be easy for us to understand, or for the developer to understand. See, I developed the code and then I left the company. I developed a project and I left the company. But then the next person, whoever is coming in my position, should be able to understand that particular software, right? So it should be understandable, learnable. So this, in terms of the stakeholders' perspective, should understand it easily. They should grasp whatever we are trying to explain. It has to be attractive. So the main user interface should be interactive and attractive to the stakeholders and the end users. Then we have the efficiency. Efficiency is how easily we can use the time and resource utilization and optimization come under efficiency. So we have time behavior. So the software should work properly in stipulated time. And resource utilization, it should optimally make use of resources. Then we have maintainability. So that is, it should be easy to maintain the software, and along with that, any modifications to be done, it should be easily modifiable. That is this. And testability, so it should be easy to test also. Then we have portability. So if I shift the program or the project from my laptop to your laptop, it should be easily understandable, it should be easily installable and adaptable to your system's configuration. So that is what the 6 characteristics are. So this question is again pretty important. It could be asked. So all these points need to be expanded and written in 1 or 2 lines each. Okay. Next, we have ISO IEC 912C and quality in use. So ISO IEC 912C also introduces concept of quality in use, which considers on how well the software performs in its intended context of use. The first one is we have effectiveness. So the software's capacity to achieve the specified goals within accuracy and completeness comes under effectiveness. Productivity. So the efficiency with which the software can make use of all the resources present or allotted to it and achieve the goals. Then we have the safety, that is, it should be secure and there should not be any harm to the data. Then we have the satisfaction, that is, user satisfaction is our utmost priority. So with this software, with this project, the user should be satisfied. Then we have what is the importance of ISO IEC 9126. So this ISO IEC 9126 is a structured approach to understand and evaluate software quality. That is the first point. It helps developers assess software based on clear criteria and measurable attributes. So here, along with this, we also have points like judge the importance of each quality characteristic. So by making use of this particular approach, we can evaluate, we can judge the importance of each quality characteristic. That is, if it is safe, like if there is any any problems which could arise, any errors which possible threats which could happen, or what is the efficiency of the system, the quality, the software and all. Then we have select external quality measurement. Here in this we can select the external quality measurement also. For example, the mean time between failures is one factor which could be considered. Okay. Then we have map measurements to use satisfaction ratings. So once measurements are defined, they should be like mapped to the ratings that reflect user satisfaction. For example, the response time should be mapped to a particular rating. Depending on those ratings, we can further rework on the project. Then we have identify relevant internal measurement. So identify the relevant internal measurement is like identifying the metric or matrices or the intermediate products during the software development. So this is important for us to ensure that the development process happens with the external quality characteristics. Okay. Next we have is overall assessment of product quality. So it is pretty important to assess the overall quality of the product. So yes, that was about the importance of ISO 9126. Then we have product based quality management. So this is again an important question asked for 8 marks or 10 marks. So here the focus is to emphasize measuring and evaluating qualities of software product. The convenience is the straightforward method, and the challenges are predict final quality when in intermediate stages. So I am in order to develop a particular software, I am in the third stage. There are totally 10 stages. So in third stage, if I have to predict the quality, it becomes difficult, right? Because I've not developed the product entirely. So that is what is one of the challenges which we face among the product-based quality management. So here we have the flow chart. So it starts with specifying the program and then program specification. Then we have the design. Then we have to design the program. Then design specification, that is program design. Then code program, test report. And on this side we have creating the test data and the expected results. And then we check with the program test data. So this is pretty much about product-based quality management. Now you need to specify these things. Specify the program. Specify the program includes all the program specifications. This is done through program specifications. So once the programs are all the technical and non-technical specifications are told by the stakeholder and specified here, we then move on to designing the program. Once the design program, then we program the design, and after that the code is generated. So once the code is generated, we look into the program part, and then the test program. For testing program, again we have product-based testing program is done. Then here we program test the data, and we create test data and expected results. So yeah, expand this and fill the pages. That's it. This diagram is what matters. As I've explained in previous videos also, SCPM being a theoretical subject, we have to write a lot of stuff, a lot of points, and we have to just fill the pages. That's it. But make sure that you draw the diagrams properly and you highlight the key points. Focus, convenience, challenges, for example, in this. Highlight the key points so that the evaluator just goes through these key points and he'll be like, okay, we have written the points and the marks code below. Next, we have principles of BSEN ISO 9001-2000. So BSEN ISO 9001-2000 provides a structured framework for companies to establish and maintain effective quality management practices. So certification to this standard demonstrates an organization's commitment to the quality and customer satisfaction. So if any company has this certification, certification of the standard, then it means that the company is following all the software quality and standards. Okay. Then while implementation can be rigorous and it could require substantial resources, it fosters consistency, efficiency, and continuous improvement. So these 3 points have been repeated from the third module itself. So in Agile we saw, in project management we saw, and here also we are encountering this. We'll look into the principles now. So here we have the principles. So the first one is customer focus. So we have to understand what are the customer expectations, what are the needs, what are the requirements, and next we have leadership. So by providing a clear direction, so that someone from the team should take up the leadership quality and guide the team properly to work towards the goal, achieving the goal. Then we have third, that is involvement of people. So here people in the sense all the employees, employees of different streams, like business or the managers or the developers or the testers or the stakeholders, the end users, all of them should be involved in all the qualities to make sure that quality is maintained. Then we have process approach. In process approach, we should make sure that all the requirements are met during the process, and that's it. Then we have system approach to the management. So viewing the organization as a network of interrelated processes, we can make sure that our management is working properly. Then we have continuous improvement. So with regular iterative improvement should happen depending on the continuous feedback obtaining from the stakeholders. Then we have evidence-based decision making. So because all the information has to be documented properly, it makes us easy to consider those things as evidence and then work on the changes. Then we have win-win condition. So again, it is pretty important for the stakeholder as well as the developers or the company people to make sure that they are in mutually beneficial supplier relationship. So the software, the team is ready to supply the services, and on the other hand, stakeholders should be ready to pay and receive the services. So next we have process capacity models. Process capacity models are those models which are generated to extensively perform testing on the particular software before it is deployed to the customer. So here in textbook we have, for our syllabus, we have 3 process capacity models, 3 topics. One is the CMM topic, and then we have the SPICE topic and Six Sigma. So CMM and SPICE are important ones. We'll discuss it. So first we have is the SCI capacity maturing model, CMM, and CMMI. So we'll look into what this is. So firstly, it is a framework for assessing and improving maturity of processes. So it has 5 maturity levels. So CMMI integrates various disciplines beyond the software engineering practices. So we'll look into the levels now. So the first level is initial level. Okay, there are 5 levels we discussed. No, first level is initial level. So in initial level, the procedures are chaotic, and they are chaotic, and ad hoc development process occurs here. So there is a lack of defined process or management practices here, but the success heavily depends on individuals rather than standardized process. Then in the level 2 we have managed. So here basic project management practices are in place. So the processes are more consistent but largely dependent on individuals only. Here also it is dependent on the individuals only. And coming to the third level, in third level it is defined. So in third level the processes are documented, standardized, integrated into organization's wide standard process. So it allows project follow those defined processes. By this we attain the consistency and repeatability. So this was about the third level. Moving on to the fourth level, we have is quality managed. So here processes are quantitatively measured and controlled. So these processes are monitored and improved based on the feedback. In level 5, we have optimizing. So again, continuous process improvement happens here. So the processes are continuously monitored and rectified depending on the whatever the changes need to be done as with the perspective of quality of the software. Before moving on to the SPICE topic, we'll look into CMMI, that is capability maturity model integration. So the CMMI model is derived from the CMM model only. But what was the need to develop CMMI model? Because in big organizations which required integrated approach that could streamline the process across multiple domains, but it was not possible with the CMM model. So to overcome that, we made use of the integration process, and CMMI was introduced as a solution. It was like a framework which integrates various CMM applications. Okay, all these could be integrated, okay, into one. So that's how CMMI came into existence. So looking at the advantages and disadvantages, CMM like it requires there are separate models for separate domains in CMM. But then coming to CMMI, here integrated model applicable for multiple domains or multiple disciplines. So here our major focus is software development. But then when it comes to CMMI, our major focus is to integrate different domains. So here there is lack of consistency in terms of process integration, but then when it comes here, it is like one process. This entire thing is like one process with multiple sub processes combined, integrated. Okay, we have discussed 3 points. 4th point is like this was the base version and it evolved. CMMI evolved from this. So if asked about CMMI, you can compare and contrast with the CMM model which we have discussed previously. So here again there will be 5 levels here. 5 maturity levels would be there, and all the advantages, disadvantages are same as the previous one. Next, let's look into the next topic, that is ISO 15504 process assessment. It is also called as SPICE. SPICE stands for Software Process Improvement and Capacity Determination. So it is a standard for assessing and improving the software development process quality. So it is based on process attributes and capacities. We evaluate the process maturity. So it makes use of processes reference model. So this reference model, keeping this as the core foundation, we developed ISO 15504. So it outlines processor in the software development life cycle. So software development life cycle comprises of research, requirement analysis, architectural design, implementation, testing, and maintenance. So now we'll look into the process attributes. So there are 9 process attributes, and in exam if they ask attributes, we should write all these. Okay, so starting from the first attribute we have is process performance. So it keeps a measure of the process specific objectives. Okay, then you have the process management. So like it evaluates how well the process is managed and controlled. Okay, then you have the work product management. So it again assesses the management of work products, like requirement specification, designing the documents, and so on. Then coming to next, we have process definition. So it will tell how well the process is defined and documented for the stakeholders or the other developers to understand. Then we have the process deployment. In process deployment, how easily or how effectively the process is deployed within the organization. Then we have the process measurement. In process measurement, it like evaluates like how well we can manage and control the process. Then controlling and managing comes under process control. Process measurement is when the specifications are made to run, when the process runs, how efficiently does it run, what is the time, space, and other resources it is being using, comes under measurement. Then we have the process innovation. So in process innovation, we'll look into the degree of innovation and improvement in the process. Suppose if we have developed the legacy process, this particular attribute would be considered. Then we have the process optimization. So it focuses on optimizing the process to improve the efficiency and effectiveness of our process. So this was about the ISO 15504 model. We'll move further. We have techniques to enhance the software quality. So the first technique we have is prototyping. So that is early working models. By developing early working models, we can avoid we can take the feedback from the customer, and requirement changes could be done in the model. Next, we have increasing visibility. So by having code reviews and walkthroughs, interaction with the stakeholder or the teammates, it becomes easy to rectify errors, find out any errors if occurring. Then we have the procedural structure. So by following structured programming, we can make sure that the quality is maintained. Then we have the component based development, that is a big software project, break it down into components. One component you work on it, achieve that, next move on to another component. Then we have inspection and reviews. So formal inspection should be done every now and then, so that we identify, rectify the any loopholes occurring in our project. Next we have the quality circles, that is quality improvement techniques need to be followed. Iteratively we should improve the quality of our software. So these are the 6 techniques to enhance software quality. This is again a 10 marks question. You should expand it. For each point write 3 or 4 lines of explanation. So now in 5th technique, to make the formal inspections, we come across Fagan inspection method. So this method is one of the inspection methods which are followed to effectively eliminate whatever the errors we can observe, and then motivate the developers to write better structured code and fostering team collaboration and improving the mutual respect and trust. So let's see how it is done. So first we plan, and after planning we brief. Okay, so the plan is first deduced and then it is briefed to all the teammates. Then they prepare for the meeting, and then meeting happens, and from the meeting whatever the feedback is given, it is reworked or considered in the plan itself. After that they follow up, do all the further necessary things post the meeting. So this is how the inspection method works. Let's look into the principles one by one. So the first principle is the inspection. So the inspection should happen properly. It should follow a structured approach. So in inspection, we should go through the design and code, and we should come up with whatever possible errors are happening in the error. We should identify them. Then we have the systematic approach. So in systematic approach, to perform the inspection, we go through step-by-step procedure. Then we have the participant roles. So here we have moderator, recorder, and a reader. Moderator is the one who leads the inspection process, a leader or a master, and he or she makes sure that the inspection guidelines are followed. Coming to a recorder note downs all the defects which are identified. Then reader guides the other participants through the document or code being inspected. Then we have the time management. So inspection meetings are structured to be efficient for short time. It could be 1 hour or 1.5 hours. It should not cross beyond that. So by this, the meetings will be effective. Instead of wasting time, if we have it for short durations, the focus and productivity of the teammates or the panel members would be maintained. Then we have use of checklists. So before getting into the meeting part, we should prepare. Here we should discuss all the defect finding processes and make sure that we speak on that in the meeting. Okay, then we have optimal inspection rate. So an optimal inspection rate is around 100 lines of code you are inspecting in 1 hour. So that is inspection rate. Okay, that will tell the efficiency in the defect detection which we are performing. Then you have the statistical monitoring. So statistics are maintained to monitor the effectiveness of inspection program process over the time. So we can make use of matrices on defect density, defect types, what are the improvements in quality resulting from the inspections. So what are the benefits from this inspection method? Firstly, we have as early detection of defects. So by having meetings every now and then, we can easily detect the error in the early stages itself and not propagate it till the end. So by doing so, we can save the time and cost also. Then we have improved quality. Because we are conducting meetings, it will be easy for the developers to identify the mistakes, and wherever the mistakes are there, we can scrutinize, work upon those mistakes, and make sure that higher software quality is achieved. Then we have knowledge sharing. By conduction of meetings, we can make sure that the knowledge is shared among all the team members, as we discuss in the group inspections, right? Then we have process improvement. So in process improvement, again, by having reviews, meetings, and a proper rapport among the teammates, we can make sure that the process happens quickly and it is easier to understand. Then next we move on to our next topic, that is black box testing and glass box testing. Glass box testing is also called as white box testing. So by definition, by the words only we can understand. In black box testing, testers don't have knowledge of internal structure or code of software. Whereas in glass box, testers have knowledge of internal structure, allowing them to design test cases and validate the internal logic. But then here you only look at the input output, you don't know what is there inside. Okay, so only input output is available, what they can access and test upon. So this is about black box testing and white box testing. Next we have verification and validation. Verification focuses on ensuring that software conforms to its specifications and requirements, whereas validation focuses on whether the software meets the user's needs and expectations. So here specification and requirements, but then here we are like it is a step ahead of verification. We validate. Okay. Next we have check whether the software is built properly or not. We verify. In validation, we see if the software is doing right job for what it was developed. So this was about verification and validation. Next we have is the levels of testing. So majorly we have 3 levels of testing. First one is the unit testing. In unit testing, the entire software project, you break down it into small functionalities, are also called as units. So you test these units one by one. Okay, so that comes under unit testing. After that, you integrate certain units and test. That comes under integration testing. You integrate all the units which are tested and now test it again. Then we have system testing. All these units combined, integration testing along with the system, you perform system testing. So here there could be errors. The testing could fail here because of the system functionalities. So it is important to perform system testing also. This is the first level, this is the second level, and this is the third level. So that's how the hierarchy is. Next we'll see how testing happens. So firstly we plan, and then we test case execution. We plan for how test case should happen, how tests should happen, what strategy should be applied, be it black box or white box testing. After that we write the test cases. So writing the test cases, after writing test cases we execute it. After execution we get the testing report. So from the report, wherever we see failure, we debug it. And after debugging, defect rectifying. So once the defects are found, we rectify it, that is solve it, debug it and then solve it. After that we perform regression testing, that is to test again, hoping that all the errors have been rectified. After that we come to the test closure. So finally the testing has been performed. Now we'll look into the types of automated testing tools. So the first one we have is capture and playback. In capture and playback, we manually sit and write the test cases and execute it only once. So during manual execution, the sequence and the values of various inputs as outputs are produced and recorded. One advantage of this is we are writing the test cases, so we'll know what it is, and we are manually testing it, so we'll know how the testing happens. But then the disadvantage is it is costly, because each and every time you have to sit and manually write, and sometimes the tests may not be valid, so there again new problem arises. Then we have automated test script. So you write a program comprising of all the test cases, and along with that you design test suites here, and automation testing is done on the software. Then we have the random input test, that is you randomly give some input to the testing to the program and test it. But then here it is very limited form of testing, because out of 10 possibilities, if you randomly select one test case, this might be true, but then rest 9 are true. We cannot be sure about that, right? So next we have is model-based testing. In model-based testing, models are like functionalities, a set of units, small programs. Here the models could be structural models or behavioral models. So structural behavioral models are like state models and activity models, and a state model like state model based testing happens through the state space described by the model. So this was about the type of automated testing tools. I have tried to cover all the important questions from the sample paper. Throughout my all 5 videos, I've mostly covered all the questions. If you have any doubts, do let me know in the comments, and subscribe to my channel. Thank you.